Welcome to BTEC Revision. In today's lesson, we're looking at moments. By the end, we will be able to recall what equilibrium is and how it links to moments, and calculate the moments on a body using the principle of moments. Let's start by looking at what equilibrium means. When a body is in equilibrium, it means two things. Firstly, the forces acting on it are balanced. Let's have a look at the forces acting on this car. Firstly, we look at the weight, which is pulling the car down. And then we have a reaction force, also known as a normal force. And that's pushing the car back up. And if the car is moving, then we could have a thrust. And there will be some friction slowing the car down if it's in motion. And in order for it to be in equilibrium, all these forces must be balanced. The vertical forces, normal and weight, must be balanced. So we can say the normal force is equal to the weight. And we can say the same for the horizontal forces. So friction will be equal to thrust. And this is true if it's in equilibrium. And the second condition is that the moments must be balanced as well. And the car could be in equilibrium even if the car is moving with constant velocity, but not if it's changing direction or accelerating. So we can say that a body in equilibrium is if there is no overall force or moment acting on it, and the forces and moments must be balanced. Now we can take a look at moments. Another word for moments is torque. What is it exactly? It is a turning force. If you have a force that causes an object to turn, then that is a moment. And we can calculate a moment by this equation here. It is equal to the force times the perpendicular distance. And we can write this in short form, m equals F times d. The units for force are in newtons and n for short, and for distance, that is meters. So therefore, the unit for moments is Newton meters. What we mean by perpendicular distance is that the force acting on this object here is perpendicular to the distance from the pivot. This is the pivot here, okay? And the pivot is a point at which the object would rotate. And the force is 100 newtons here, and it's acting perpendicular, which is 90 degrees to the distance here. The distance is horizontal and the force is vertical. Now, in order to calculate the moment, we can write moment equals force times distance, perpendicular distance, and that's equal to 100 newtons of force multiplied by a distance of 10 centimeters. And we know a centi is equal to 10 to the power of minus 2. Calculating this, we get 10 Newton meters. Next, let's take a look at the principle of moments. This states that the total clockwise moment equals the total anti-clockwise moment. For example, if you look here, we have a 10 Newton force and we have a pivot here. And what's going to happen is that force of 10 Newtons is trying to pull this rod down, and that would make a clockwise pattern. If you carry on going in the circular motion, you would see it would go around in a clockwise motion. And then we have the 4 Newton force over here, and that is pulling it down in the anti-clockwise direction. Okay, so we can say that the total clockwise moment is 10 newtons multiplied by the distance from the pivot, okay, which is perpendicular to the force, and that's d, and that's equal to 4 newtons of force times the perpendicular distance of 10. So we can rearrange this equation now for d. We'll make d the subject, and therefore that's d equals 4 times 10 divided by 10. 10 is going to cancel, and we're left with 4 meters. So that means this distance, d, must be 4 meters. And if that's true, then this object is going to be in equilibrium. Okay, so the principle of moments is true if the object is in equilibrium. Now pause the video here and attempt this exam question. In order to solve this question, we'll have to use the principle of moments, which states that the total clockwise moment is equal to total anti-clockwise moment. Now we can have a look at which points are clockwise. So we can look at the 100 Newton force is going to make a clockwise moment against the pivot. And we also have the 15 Newton force, which is also going to make a clockwise moment. So we can start by writing 100 newtons times 10 centimeters. Okay, and we're going to leave the units in centimeters because on both sides they will cancel out, and are working out force anyway. So if they cancel out on both sides, we'll still have force measured in newtons. And the second moment, we can add 15 times 5 centimeters, which is the perpendicular distance. Now we can look at the total anti-clockwise moment. So we have force times 10 centimeters. So that's 10F. And the last one, 20. Now if you look here, we have a distance which is perpendicular from the pivot. That's going to be 5 and another 5. So that's actually 10 times 20. So that's 200. 100 times 10 is going to give us 1,000 plus 75 is equal to 10F plus 200. Okay, rearranging this, that's going to be 10F is equal to 1,075, take away 200, which is 875. Therefore, F is equal to 87.5 newtons. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions, and there's lots more resources available at btecrevision.com. See you next lesson.